Alright guys, this is my tutorial on pedigrees. Pay close attention, you're going to get a quiz over this tomorrow. So I just mentioned on the previous slide that a pedigree is a useful tool for geneticists. And what they do is they try to predict the probability. And so it's a tool much like Punnett squares, and we actually use it with Punnett squares to determine what is the probability that something will be passed on from generation to generation. And really what it helps us try to understand is the genotype. The genotype of parents and grandparents and things like that. That's what we really use a pedigree for. So here is a pedigree. You can see here that it's a visual representation of genes being passed from generation to generation. And a couple things I want you to notice about this pedigree that are important is, first of all, here is a key at the bottom of this pedigree. It may not be on the bottom. It could be at various locations. Something else that's very important to note, and is here in the PowerPoint, is that males in a pedigree are typically represented by squares and females are represented by circles. And so in this pedigree you can see this here is a male, this here is a female, and that's important information for you to know. Some other things to notice about this pedigree are a completely filled in circle or square shows that the trait exists in that person. In this case, a filled in is represented by purple, and so a purple square represents a colorblind male. We don't have any females that are colorblind in this pedigree. A half-colored circle represents a carrier, and down here in the key you can see a carrier coding. You'll also see that an empty circle or square is not a carrier of the trait or exhibit that trait at all. Again, in this pedigree it's not as much empty as it is, they've coded it as yellow as being empty in this particular pedigree. So if you would, let's take a look at your green packet at this time. And what you can see here is a practice problem for a pedigree. And in this particular pedigree, we see the key over on this side here. Remember, the squares represent males, the circles represent females. The particular disease we're looking at is called Huntington's. Huntington's disease is where the nerves degenerate over time, and this causes several symptoms, and usually from the onset of Huntington's, according to eye research, death will occur in about 15 to 20 years after it's diagnosed. It's caused by an abnormality in chromosome number 4. And so looking at this pedigree, we can see how it is passed down from generation to generation. And there are several questions I could ask about this particular pedigree, and you can see those below, and let's go through those questions and see how we do answering them. So question number 1 says, looking at this pedigree, how many children did generation 1 parents have? You should be able to read a pedigree and see that the generations are, this is generation 1, this is generation 2, and this is generation 3. To determine children, you have to follow the line. So this line here connects to, if we go here, we follow it, we see one child, a boy, another child, a boy, another child, a girl, another child, a girl, and another child, a girl. So if we count, they had 1, 2, 3, 4, 5 children. So how many children did generation 1 parents have? The answer there is 5. One thing I want to point out quickly with this pedigree is that there's some other information here. This person, this female, and this male are not children of these parents from generation 1. They have married their children, and so you will see that there is no line connecting them to the parents there. So that tells us that these are not children of those parents. Moving on to question number 2. In generation 2, how many people did not have children? You have to look very closely here. Again, this is generation 2, and we can see that this female did not have any children, as well as this female did not have any children, because there's no line going down connecting them to the 3rd generation. So the answer is 2 people in the 2nd generation did not have children. On to question 3 now. How many girls did couple number 3 and 4 in generation 2 have? How many boys, how many girls? So if we look at generation 2 and we identify couple 3 and 4, we can look at their children by following the line down, and we can see that they had 2 girls and 1 boy. So to answer that question, how many children did they have? They had 3 children with 2 girls and 1 boy would be the correct answer for that one. On to question 4. How many children do couples 7 and 8 have, and what percentage of the children have Huntington's disease? Again, that couples 7 and 8 are in the 2nd generation here, and we have to look at their children, which is below, and we can see that they have 4 children. So we would write the answer 4 children. And what percentage had Huntington's disease? We can see that this girl is Huntington's disease and this boy is Huntington's disease. So that's 2 out of 4 children, so 50% have Huntington's disease. And in question 5, how many people had Huntington's disease over 3 generations? We have to count all the people who had Huntington's there. And so if we do that, we have to go back up to the top of the pedigree a little bit. So 1, 2, 3, 4, 5, 6, and 7. So 7 people over 3 generations have had Huntington's disease according to this pedigree. Now what I'd like you to do is to pause the recording for a moment and try to answer the questions for the next page's pedigree in your green packet. That's this one you see here. On yours it's obviously black and white, but the key should be pretty much the same. This is a pedigree for the royal family in England, and it's for the disorder called hemophilia, and we talked about that in class. So study the pedigree, try to answer the questions the best you can. I'll go over them momentarily. Okay, let's go through the questions now. Question number 1 says, looking at the pedigree above, focusing on Alice and Louis of Hesse, that's these 2 right here. It says, how many children did they have? And you should count the children as being 1, 2, 3, 4, 5, 6. So a total of 6 children. How many of the children from the question above were hemophiliacs? There's really only 1 that would be considered a hemophiliac. And how many carriers were there? There's 2 female carriers, so the answer to that one is 2. Okay, moving on. It says, looking at Beatrice and Henry in the 3rd generation. The generations are a little harder to tell in this pedigree, but we see Beatrice and Henry here. This is the 3rd generation row, and the other 2 are above it, though they only have one couple in each of those generations on this pedigree. It says how many children did they have. So again, we count how many children, follow the down lines from them. So I have 1, 2, 3, and 4. So the answer to that one would be 4. And the next question, how many boys, how many girls? And so we have to look again close at that. Of the 4 children, I will circle the boys. 1, 2, 3 boys. So 3 boys. And the other one is a girl then. So this would be the answer to that question. So then the final question dealing with Beatrice and Henry is how many of the children were hemophiliacs? And if we again study the pedigree, we can see that this boy and this boy are hemophiliacs. So the answer to that would be 2. And so I will write a 2 there for the answer and move on to the next question. The next question is, what pattern do you notice about this disorder? And to answer that, you really have to study the pedigree a bit. And if you look closely and pay attention, you will notice 2 things. Number 1, that it's all males that are affected with this disorder. And 2, the carriers are females. So that is the answer to that question. And then the final question, how many generations are represented in this pedigree? I'll go back to the pedigree and draw that. I already pointed out up here that this was the 3rd generation. This is the 1st. This is the 2nd, writing Roman numerals here. 3rd, and then this is 4th, 5th, 6th. And there is one more. This one here is the 6th, but this group is included in that if you look at the line actually. And then, so this is actually the 7th generation. So there are 7 generations that are represented by this pedigree. All right, that's it. Hope you have a good night. We'll see you tomorrow.